Imagine raising 7.4 billion US dollars to build the world's most advanced AI,
Yeah.
building up, just an immense amount of industry anticipation, and then releasing your highly anticipated software update without changing the underlying engine at all.
Yeah, it sounds completely counterintuitive, right? I mean, especially in a sector where progress has historically just been defined by raw scale. You'd naturally assume that billions of dollars in fresh capital translates directly into a much larger, more resource-intensive neural network.
Exactly. But that is the exact scenario we're looking at today.
Hmm.
Welcome to this deep dive into the official release of DeepSeek V4 Flash Unit 0731, which dropped on July 31st, 2026.
Right.
And we're parsing through a really comprehensive technical guide from OscarAI that analyzes this launch. Our mission for today is to cut through all the heavy technical jargon and the inevitable social media noise to answer a critical question: is the world's cheapest AI actually good?
Which is the big question.
Right. And beyond just the performance metrics, what is this specific launch signal for developers and the broader global tech landscape?
And that is incredibly relevant for you listening right now because, whether you're a developer looking to migrate an enterprise application or you're simply trying to navigate this dizzying AI arms race against frontier models like GPT 5.4, Gemini 3.1 Pro, and Claude Opus 4.8, understanding this specific DeepSeek release offers a clear advantage.
Oh, absolutely.
It illuminates where the industry is structurally heading, completely decoupled from the standard marketing hype.
Okay, let's unpack this, because the financial context surrounding this release is just impossible to ignore. DeepSeek didn't merely push an update to their API endpoints, they just closed a private funding round of nearly 50 billion yuan.
Which is massive.
Yeah, that translates to about 7.4 billion US dollars, backed by major players like Tencent and NetEase. And that capital injection pushes DeepSeek's total valuation to an estimated 350 billion yuan.
Right, and when you see that level of institutional investment, your immediate expectation is a paradigm-shifting technical architecture. I mean, the assumption is they built a completely new, vastly larger model to justify that valuation.
But that brings us to the core irony of this July 31st launch. The physical architecture of this new model is entirely unchanged. The core engine is the exact same one they unveiled months ago.
Yeah, we should probably establish the timeline here just to keep the facts straight. The V4 family originally launched in a preview state back on April 24th, 2026.
Right.
And the family is built around two primary models. First, you have V4 Pro, that's the heavyweight model, featuring 1.6 trillion total parameters.
Which is a huge number.
It is, but it utilizes a mixture of experts architecture, commonly referred to as MOE. So instead of activating all 1.6 trillion parameters for every single word it generates, the system acts like a highly efficient router. It only activates the specific 49 billion parameters, the experts that are most relevant to the specific token being processed.
Got it. And the second model is V4 Flash, which is the specific focus of today's update. Flash is the highly optimized sibling. It features 284 billion total parameters, but its routing mechanism only activates about 13 billion parameters per token.
Exactly.
And both the Pro and the Flash models share a 1 million token context window, allowing them to ingest and recall roughly the equivalent of several large novels in a single prompt.
But the critical takeaway regarding the architecture is that the parameter counts, the MOE routing mechanisms, the physical infrastructure, none of that was altered on July 31st.
Right. When I was reading through the OscarAI guide, the concept of post-training really stood out as the differentiator here.
Yeah, it's key.
Since we aren't dealing with a new architecture, all the improvements came from post-training optimizations. It's like, instead of using the tired analogy of dropping a bigger engine into a car, it's more accurate to compare this to taking a brilliant but highly chaotic savant and rigorously teaching them how to organize their thoughts into a structured spreadsheet.
Oh, I like that framing. Pre-training is where the model acquires its raw intelligence. You feed it vast swaths of the internet, consuming millions of dollars in compute, just so it learns the statistical probability of language and general world knowledge. It's the chaotic savant.
Right.
Post-training is the refinement process.
And the OscarAI analysis notes that DeepSeek completely retuned the model's behavior during this phase. They applied rigorous reinforcement learning and instruction tuning heavily focused on coding, acting as an autonomous AI agent, executing complex reasoning chains, and interacting with external software tools.
Yeah, they basically taught the savant how to format its brilliance for enterprise environments. What's fascinating here is how directly this challenges the entrenched Silicon Valley narrative.
Oh, totally.
For years, the prevailing doctrine has been that scale is all you need. Like, if you want a more capable AI, you must continuously add parameters and exponentially increase compute
So
power.
just build a bigger brain.
Right. But DeepSeek is demonstrating that refining the post-training pipeline, optimizing data quality, improving rejection sampling, and tightening those reinforcement learning feedback loops is where the most lucrative efficiency gains actually exist right now.
So you extract vastly superior utility out of the exact same 13 billion active parameters simply by rigorously teaching the model how to structure its logic.
Precise.
And this translates to a highly practical benefit for developers. Because the underlying architecture remains static, the API infrastructure didn't require an overhaul.
Right, which is huge for stability.
Yeah, if your application was already routing requests to the DeepSeek V4 Flash API endpoint before July 31st, you didn't have to rewrite any code. The deployment was completely seamless.
Seamless continuity is highly valued in enterprise software for sure.
Yeah, your application's response latencies remained identical, the pricing remained identical, but the model handling your requests suddenly became significantly more adept at following complex formatting instructions.
But, if the physical architecture remains static, we have to look closely at how we actually quantify this improvement in reasoning and formatting. We have to look at the data.
Yes, let's examine the report card, because this is where the rollout generated a significant amount of friction in the developer community. DeepSeek's official press release made some pretty aggressive claims.
They did. According to DeepSeek's internal reporting, this newly optimized V4 Flash now substantially outperforms the April preview version of their much larger V4 Pro model across 9 distinct agent capability benchmarks.
Wow.
Yeah, they specifically highlighted a score of 82.7 on Terminal Bench 2.1, which evaluates how effectively an AI can autonomously navigate and execute commands within a computer terminal environment.
Okay, that's impressive.
Plus, they announced native fluency in the Responses API format, ensuring perfectly structured data outputs alongside dedicated integration for the Codex programming tool.
But I have to pause on those benchmark claims. While I was reading the source material, a glaring issue jumped out at me. A number of the tests DeepSeek cited to prove their superiority. Specifically, DSBench Full Stack and DSBench Hard are DeepSeek's own internal benchmarking suites. We are essentially watching a student write their own final exam, take the test, and then issue a press release about getting a perfect score.
Your skepticism is entirely warranted. I mean, this brings up a chronic issue in machine learning evaluation known as benchmark contamination or overfitting.
Right.
When a laboratory creates its own evaluation metrics, there is a very high probability that the logic structures or even the specific data points from those tests inadvertently bleed into the post-training pipeline.
So they basically memorize the answers.
Exactly. The model isn't necessarily getting universally smarter. It has simply memorized the rubric of the test it knows it's about to take.
And that perfectly explains the discrepancy when you cross-reference DeepSeek's claims against independent data. The OscarAI guide highlights that on platforms like Code Arena, which relies on crowdsourced, blind A/B testing of code generation rather than static, easily memorized benchmarks, the V4 Pro model is currently ranked 35th.
Yeah, that's quite a drop.
And the reasoning variance sits at 31st. It is underperforming against regional competitors like GLM 5.1 and Kimi K2.6, and it remains distinctly behind Western frontier models, particularly Claude Opus 4.8.
Well, the blind A/B testing on Code Arena provides a much more rigorous evaluation of practical utility. Humans are prompting the model with novel problems it hasn't seen before, which exposes the limitations of its reasoning capabilities out in the wild.
Here's where it gets really interesting, though. This discrepancy ignited a massive firestorm online. When those independent rankings circulated, Western tech analysts on X immediately branded the entire V4 model family as slang for entirely mediocre.
Oh, I saw that.
Yeah, and that assessment triggered a fierce, highly polarized backlash from the Chinese AI community, devolving into a massive digital argument over whether this heavily funded model was a failure or simply being evaluated on the wrong merits.
Context is crucial when evaluating these polarized debates. And I want to be clear here, the analysts dismissing the model as mediocre based on comparisons to Opus 4.8 are engaging in a chronological fallacy.
How so?
DeepSeek deliberately engineered and positioned the V4 family to compete with Gemini 3.1 Pro and GPT 5.4. Claude Opus 4.8 did not exist in the marketplace during V4's development cycle.
Okay. Opus 4.8 dropped later, shifting the entire baseline.
Yes. Any head-to-head documentation circulating online showing Opus 4.8 dismantling V4 originates from third-party testers. As objective analysts of this source material, our role isn't to validate one side of a social media dispute.
Right, of course.
The fundamental takeaway is that evaluating a model finalized in early summer against a heavier next-generation model released in August lacks scientific rigor, especially when it ignores the creator's stated design parameters.
That makes sense. And it leads to a highly logical question for you as a listener trying to make sense of this industry. If V4 Flash is sitting at 35th place on independent leaderboards and prominent analysts are dismissing its capabilities online, why did Tencent and NetEase confidently pour $7.4 billion into the ecosystem?
Right, because institutional investors of that caliber do not deploy billions of dollars to capture 35th place on a technical leaderboard.
Exactly. The answer isn't in the code itself. It is found in the underlying economics.
DeepSeek has meticulously executed a highly disruptive pricing strategy since the launch of their R1 model in January 2025. Their thesis is clear offer, acceptable, highly competitive performance at an aggressive fraction of the market cost.
Let's break down the actual numbers because they are genuinely jarring.
Yeah.
On May 31st, 2026, DeepSeek made a 75% price reduction on their Pro model permanent.
Right.
And following this V4 Flash update, the cost structure is almost microscopic. The API charges $0.435 less than 44 cents per 1 million input tokens for a cache miss.
We should briefly clarify the significance of a cache miss in this context.
Oh, sure. A cache miss basically means the API is processing entirely novel text that it doesn't already have stored in its short-term memory banks. Computing novel text requires significantly more active processing power from the GPUs, which is why most AI providers charge a premium for it.
Yeah.
But DeepSeek is executing that heavy lifting for under $0.50 per million words. And the output generation cost is equally aggressive, sitting at just 87 cents per million tokens.
So apply those unit economics to a real-world enterprise architecture. Imagine you are deploying an application requiring immense daily volume, perhaps an automated document processing system analyzing thousands of lengthy legal contracts, or, I don't know, a customer service infrastructure handling millions of localized interactions.
If you are operating that infrastructure in an emerging market, say Latin America or parts of Southeast Asia, where local currencies face unfavorable exchange rates against the US dollar, the delta between Western API pricing and DeepSeek's pricing is not some minor accounting detail.
Oh, not at all.
It is the literal difference between a highly profitable product and total insolvency. You rarely need the cognitive power of an Opus 4.8 to summarize a standard refund policy. You need a model that is functionally competent and ruthlessly inexpensive.
If we connect this to the bigger picture, we see a deliberate geopolitical maneuver here, too. On the exact same day, DeepSeek announced the V4 Flash 0731 update for their API. They uploaded the complete model repository to Hugging Face.
Totally free.
Yes, they released the open weights entirely for free, governed by a highly permissive MIT license.
Which means any developer can download the actual neural weights, the actual brain of the AI, and run it locally on their own physical hardware. You can bypass the DeepSeek API entirely if you have the compute capacity.
Exactly.
While Western AI labs are increasingly constructing closed, proprietary walled gardens around their frontier models, DeepSeek is effectively distributing a highly capable, enterprise-ready engine to the global public square.
And the implications for digital sovereignty are profound. Any enterprise, research institution, or foreign government can now host this architecture internally. They can deploy advanced AI capabilities without transmitting sensitive data through a foreign-controlled API endpoint, which is an immensely powerful selling point for data-secure environments.
Definitely. And speaking of that Hugging Face repository, the OscarAI guide highlighted a brilliant technical Easter egg hidden in the release files.
Oh, the parameter count discrepancy?
Yeah. If you examine the public repository, Hugging Face lists the model size at 304 billion parameters.
Wow.
But as we discussed earlier, V4 Flash is structurally a 284 billion parameter model.
Right.
I spent some time unpacking this, and I realized where the extra 20 billion parameters came from. The public checkpoint includes an integrated module called DSpark, which handles speculative decoding.
Right, and speculative decoding is an elegant solution to one of the most persistent bottlenecks in local AI deployment memory bandwidth.
Think of DSpark as a highly aggressive autocomplete assistant bolted onto the side of the main neural network. In a standard setup, an LLM generates text one single word at a time. constantly checking its massive memory banks for every single step. It's computationally slow.
Very slow.
But with speculative decoding, the smaller 20 billion parameter DSpark model instantly guesses the next 5 or 10 words in a sequence. Then the larger 284 billion parameter main model just looks at that entire drafted sentence simultaneously and either verifies it or corrects the specific errors.
Right. And by processing a batch of drafted tokens in parallel rather than generating them sequentially, you drastically reduce the memory bandwidth bottleneck. The inference speed, the time it takes for the model to actually reply to the user, accelerates dramatically.
So smart.
Including the DSpark module in the public release really underscores DeepSeek's commitment to optimizing the developer experience for local deployments. They aren't just giving you the model, they are giving you the tools to run it efficiently on constrained hardware.
Because they are pushing this aggressive open-weight strategy alongside rock-bottom API pricing, developers are rushing to integrate V4 Flash into their tech stacks. But if you are one of those developers doing this today, your application might actually crash if you miss a critical piece of technical housekeeping detail in the source material.
Yeah, we have to mention this. The OscarAI guide includes an urgent deprecation warning.
Right.
The legacy API identifiers, specifically the endpoints labeled DeepSeek Chat and DeepSeek Reasoner, have been permanently retired. They officially went offline on July 24, 2026 at 15.59 UTC.
The directive is straightforward. If your code base is still routing requests to those deprecated identifiers, your software will fail. You must migrate your environment variables to point toward the new V4-specific endpoints immediately to maintain service.
Furthermore, it is vital to clarify the current deployment status of the broader V4 ecosystem to avoid architectural confusion. This entire July 31st event, the enhanced post-training, the optimized reasoning, the codex integration, applies exclusively to the V4 Flash model.
Right, the lightweight sibling.
Correct. The official production-ready version of V4 Pro remains in preview state. DeepSeek's internal communications indicate the finalized Pro version will be deployed, quote, as soon as possible, with full support for the Responses API and Codex anticipated sometime in early August 2026.
Good to know.
Additionally, if you are an end user interacting with DeepSeek via their consumer-facing web interface or mobile application, you will not see these improvements yet. The July 31st rollout is strictly an API-level upgrade targeted at enterprise developers.
So what does this all mean for you as we synthesize the benchmark data, the engineering optimizations, and the sheer volume of capital flowing into this ecosystem? DeepSeek V4 Flash 0731 is not attempting to win a technical beauty pageant against Western frontier models.
No, they aren't.
They're not trying to engineer the most hyper-intelligent, all-knowing entity on the planet. This launch represents a heavily capitalized laboratory, relentlessly optimizing the single variable that dictates enterprise adoption at scale unit economics.
Exactly.
They took a competent, existing architecture, rigorously refined its ability to execute corporate formatting tasks, and pushed the price point so low that it forces the entire global industry to recalculate their margins.
We are witnessing the rapid commoditization of artificial intelligence. By distributing open weights and slashing API costs, they are accelerating the transition of AI from a premium luxury software product into a fundamental digital utility, much like cloud storage or internet bandwidth. But observing this strategy unfold raises a structural question for the industry at large, and it's something for you to think about. As we watch this intense price war accelerate through 2026, is a race to the bottom on token economics actually sustainable for these laboratories long term? Or will the market eventually force a correction, requiring these companies to abandon the price war and return to competing exclusively on verified, groundbreaking architectural capabilities?
That is the multi-billion-dollar question underlying this entire arms race. You can optimize the post-training pipeline to perfection, and you can reduce the entry fee to practically zero to capture the market. But eventually, a competitor is going to finalize a fundamentally new architecture that shatters the current ceiling of reasoning capabilities.
And then everything resets.
We will have to see how long optimized efficiency can hold the line against raw next-generation scale. Thank you for joining us on this deep dive into the DeepSeek release. If you are building software right now, we highly encourage you to review the OscarAI documentation, spin up the new API endpoints, and run your own unit tests. Evaluate the latency, check the economics against your current infrastructure, and determine if highly optimized, commoditized AI is the missing variable in your next deployment. We'll catch you on the next one.